So this is an extension of prime factorization. It's just saying if we have repeated primes multiplied together, can we organize it such that it's going to be in exponential form, right? So if I have 2 times 2 times 3 times 5, I would write it as 2 squared times 3 times 5. And again, we're coming up with new notation right here. So when I type it, it's the asterisk, but right now we could actually have a dot, and that means the same thing as multiplication. So again, this means 2 squared times 3 times 5. We're going to go ahead and just really power through this and see how quickly we can do it. So I have a sheet of paper next to me in case I need to do any more challenging problems, but we'll go ahead and see what we can do. And by the way, when we look at it, what I just did there was I put 2, and then I used the caret symbol, which is the little upward pointing kind of hat. It's above the number 6, so shift 6, and then it'll give you the exponent. And so I can say, just like that, that would be 2 squared, which equals 4. So, going on from here. Prime factorization of 8 is 2 cubed. Prime factorization of 9 is 3 squared, right? 3 times 3. 18, 2 squared times 3. I'm going to try using an asterisk just to see how this goes. Sorry, that is my bad. Going back, that was me making a mistake. So 2 squared times 3 is actually 12. What I meant was 2 times 3 squared. So that's totally my bad, but again, we'll go from here. So 4 is 2 squared. 20 is 2 squared times 5. Over here, 15 is 3 times 5. 6 is 2 times 3. 16 is 2 to the 4th. 30 is 2 to the 5th. 45 is 3 squared times 5. Oops. Times 5. Don't want to multiply up there. Right? 30 is 2 times 3 times 5. 10 is 2 times 5. 42 is 2 times 3 times 7. 28 is 2 squared times 7. 56, and I can use a little bit of a multiplication table here. I say 7 8 56, so I know 8 is 2 cubed times 7. 90. And for some of these numbers, you should practice breaking it down, right? So earlier you saw how I had memorized essentially the 2's, the powers of 2. So I think 2 to the 1 is 2, and then 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, 8192. These are all powers of 2 that have come in very, very handy for me over the years. Not for necessarily math, but actually when I'm dealing with anything that's related to computers, in terms of memory, in terms of storage space. The idea of 2 is just very, very useful. Anyways, not to cut you off, but for 90, whenever I see a 0, automatically split it off, so it's going to be a 10, and then so basically you're going to have 9 times 10, so 3 times 3 times 2 times 5. Organize that as 2 times 3 squared times 5, right? Going on from here, this is 2 squared times 5 squared, right? So 4 times 25. 27 is 3 cubed. 70 is 2 times 5 times 7. As we go from here, 24, this is 3 times 8, so 2 to the 3rd times 3, right, because we know how to factor 8. 77 is 7 times 11. It's really great to have this pattern right here because, again, if it repeats like this, then it's definitely divisible by 11. 75 is 3 times 25, right, and 25 is just 5 squared. 66, right, so 2 times 3 times 11, that 11 pattern comes up again. 55, 5 times 11, really great. 44. Now, again, don't fall for the tricks, right? Sometimes you'll get eager and then you'll write 4 times 11, but 4 is 2 squared times 11. And that'll be correct. 12 is, now this is the one where I missed earlier. I mistook this for 18, but And 2 squared is 4 times 3 is 12. 25 is 5 squared. 22 is 2 times 11, wonderful pattern. And then 35 is 5 times 7. So really we can do this pretty quickly, all right? But this is how we're supposed to go.